Our first problem on spring mass system is the system shown in the figure is in equilibrium. Find the initial accelerations of blocks A, B and C just after the spring 2 is cut. The springs 1, 2 and 3 are shown in this diagram. Blocks of mass M, 2M and 3M are shown here. Let the extensions in spring 1 is spring 1, 2 and 3 are x1, x2 and x3 respectively. That is x1 in spring 1, in 2 it is x2 and in 3 it is x3. So the force in this spring will be kx3 and in spring 2 it is kx2 and in spring 1 it is kx1. Force, if we show the blocks of mass M, 2M and 3M. M, 2M and M. Then in equilibrium, the forces on blocks M, 2M and 3M are kx1 in upward direction, it is spring force due to extension in spring 1, and kx2 in downward direction due to extension in spring 2, extension x2 in spring 2, and a gravitational force mg will also act in downward direction. On block of mass 2m, spring 2 applies force kx2 in upward direction, and due to spring 3 a force kx3 will act in downward direction, and a gravitational force of magnitude 2mg will also act in downward direction. And on block of mass 3m, force kx3 will be in upward direction, and a gravitational force 3mg will be in downward direction. In equilibrium, kx1 will be equal to kx2 plus mg, comma kx2 will be equal to kx3 plus 2mg, and kx3 will be equal to 3mg. These equations or equilibrium conditions are shown here. All equilibrium conditions are given here. For block of mass 3m, the condition is this, and for block of mass 2m, the equilibrium condition is this, and for block of mass m, the equilibrium condition is this. Equilibrium condition is this. For this block, 3 mg is equal to kx3. 3 mg is in downward direction, kx3 is in upward direction. So 3 mg is equal to kx3. For this, kx3 plus 2 mg, kx3 plus 2 mg is equal to kx2. Substitute the value of kx3 from equation 1 in this equation. You get 3 mg. 3 mg is the value of kx3 plus 2 mg is equal to kx2. So 5 mg will be equal to kx2. It is equation 2. And from this ability of mass m, kx1 upward directional force is equal to kx2 plus mg. The value of kx2 is 5 mg. 5 mg plus this mg is equal to 6 mg. It is your equation 3. Note that when spring 2 is cut, the force on spring 3 and spring 1 will remain unchanged. Only the force in spring 2 will be equal to 0. In this spring, there will be no force. And in spring 1 and spring 3, the force will remain unchanged. So, for block of mass m, the forces are kx1 in upward direction and mg is in downward direction. Mg is gravitational force. Note that in this case, the downward spring force in downward direction, spring force in downward direction due to spring 2 is 0. So the condition of motion for this block will be kx1, it is in upward direction, plus minus mg, which is in downward direction, is equal to ma1. A1 is the acceleration of block m. Substitute the value of kx1, which is 6 mg, minus mg is equal to ma1. From here we get a1 is equal to 5g. This acceleration will be in upward direction. Now for block 2m, the condition of motion is the force kx3 is in downward direction due to spring 3 and gravitational force is also in downward direction. So net force on this block is kx3, which is in downward direction. 2mg is also in downward direction, is equal to 2ma2. 2m is the mass of this block. So we get a2 is equal to 5g upon 2. a2 is the acceleration of this block. And for block 3m, the downward gravitational force is 3mg and upward spring force is kx3. So equation of motion is 3mg minus kx3 is equal to ma3. a3 is the acceleration of mass 3m, as kx3 is equal to 3mg. So 3mg minus 3mg is equal to ma3. Sorry, the mass is 3ma3, implies a3 is equal to 0. A3 is equal to 0. So the acceleration of block 3 is 0. Is 0.